Hello, ladies and gentlemen. So this will be a demonstration on how we as a group we finished part one of lab E1. So here, as you can see, we were asked to demonstrate the schematic circuit one, which consists of two NOR gates. And here on the breadboard, we plotted the IC for the NOR gate, and we plotted the jumper wires so that this circuit can function. So here basically, according to the truth table, when A is 0 and B is 0, the value of the output will be 0, so no light will show. And according to the truth table, when A is 0 and B is 1, as we demonstrate here, the output will be 1, as shown in the table. Next, when the value of A is 0 and when the value of A is 1 and B is 0, we go here for A input. The output is 1, as shown in the table. And lastly, when both A and B are 1, the output is 1. And that's how we've proven the truth table using the IC. So here we are again, and this time we are going to prove the truth table for the schematic circuit 2. So as you can see here, we've set up the following circuit in the breadboard. And based on the truth table, when both values of A and B are 0, the output is 0, as we can see here. And when the input of A is 0 and 1 is B, the output is 1, as portrayed in the table. And also when A is equal to 0, when A is equal to 1 and B is equal to 0, the output is 1 more time. And lastly, when both A and B are 1, the output must be 0. Therefore, the LED will not show, as we can see in the breadboard. So good afternoon. In this video, we'll be finding the total propagation delay and voltage levels for a wired 4 NAND gates as series of inverters. So first of all, we would adjust the blue graph in order for us to find the voltage. And so basically we select the high edge graph, and then we go to the cursor, and then we change the mode to manual. We change the mode to manual, and then now we adjust it to channel 2 in order for us to find the voltage. And now we adjust the cursor A, and we adjust it to be right at the top of the blue graph in the top line. And for cursor B to be at the low edge. So now, as it is seen in the screen, the high curve gave us 3.32 voltage, while the lowest curve gave us 0.00 voltage. Okay, since we found the voltage, now we are required to find the total propagation delay. So first we choose the high edge, and then we adjust the cursors. We go to the cursor menu, manual, and most importantly is that we switch the source to channel 1. And now hereby we can adjust both cursors. First of all, cursor A is supposed to be placed in the middle of the yellow curve. I think we need to zoom in. To get a better. So now we must adjust, and we need to change the type to time so that the cursors are set vertically. So now it's channel 1, yes. So now for the first cursor, we must adjust it in a way that it's in the middle of the curve in the yellow graph. And for cursor B, we do the same thing, but for the blue graph, which is right in the middle of the curve. Yeah, so it must be behind the x-axis, the y-axis, and therefore we get a result of of 76. So that's the change in time. That's the total propagation delay for the high edge graph. And then for further calculations, we divide it by 4 to get the total propagation delay. Now we do the second part of it, which is that we find the total propagation delay for the low edge graph. And then we get this graph, but we zoom in to get a better picture of the graph, to place the cursors in a precise manner. So it's the same kind of details, the channel 1 and type is time. So now we adjust the first cursor to be in the middle of the curve of the yellow graph, and we adjust the second cursor to be in the middle of the curve in the blue graph. So as we can see here in the screen, we get a total propagation delay of 62 nanoseconds, which we then further on divided by 4 to get our final answer. So moving on to the third part of this lab, we're asked to construct and confirm the operation of this circuit provided in the lab. So the basic aim is to let this LED work after combining the NAND gate with resistors and supplying VCC and ground power. So the main aim, as I said, is to let the LED work as soon as we click on the switch. So here we've chosen switch number 3 as the output. So as we press on switch number 3, the LED goes on. Moving on to the last part, which is part 4, we were asked to design a schematic circuit as shown over here to verify the following truth table. In a sense, when two or more values when two or more inputs, either A, B, or C, is 1, then the output is equal to 1. So therefore we came up with this schematic circuit, and then we basically, as you can see in the breadboard, we have one double NAND input IC and one triple NAND input IC. So the final output of the circuit is that when two or more values are pressed, then the output is 1. So when it's A only, we see there's no output. When it's A and C, the output is 1. When it's A and B, the output is 1 as well. When it's B and C, the output is 1. And when all three are pressed, then the output is 1. And in that manner, we verified the truth table here.